Welcome, everybody. The next session is going to be focused on a very interesting open source technology, K3s. Some of you might already be familiar with this specific Kubernetes distribution. We're really glad because Keith Basil, the general manager of SUSE's Edge business unit, has been able to join us. Even he's not been able to join us live, but he's been kind enough to send us a recording of his presentation. Today he's going to be exploring the challenges and the many opportunities of K3s and the rest of open source technologies that are now a part of SUSE's portfolio, some of them coming directly after the acquisition of Ranger. From our perspective, K3s has been a very interesting technology to integrate as part of our capabilities for managing application containers. As you know, we manage a number of technologies there. For us, K3s is going to play a very interesting role at edge locations. If you've been familiar with the publications we've been producing this couple of years doing the ONEedge project, you'll be aware that our K3s distribution is able to self-register on Ranger. So one of the challenges that some of our users and partners have been dealing with is precisely that. So being able to use OpenNebula for deploying the K3s clusters. But after that, they need also to be aware of the challenges of managing all these K3s clusters at a scale. So K3s clusters being deployed in very large numbers in very remote locations, some of them with some challenges like lack of connectivity. Sometimes that's on board of a moving vehicle. So today we have Keith, and he's going to give us some insights about both the technology and also the vision from SUSE about the challenges and opportunities in edge computing in the future. So I'll leave the floor to him.
First, I wanted to say thank you for the opportunity. It's good to be with you and with the conference and such. So just give me a few minutes and I'd like to give you our high-level vision for how we see the edge, and then we can segue into how we see K3s as a brilliant piece of technology addressing the challenges that we see at the edge. So let's just jump right into it. So one of the first things that I like to do is set a baseline definition of what the edge is, right? And so in terms of defining the edge, this allows us to have a very intelligent conversation about the problems and the solutions and just the general nature of how we need to think about deployments at the edge. And so in using this framework, and you'll see us repeat this over and over again as we talk about the technology stack, we like to talk about the three segments of the edge, right? And so the first one that we see, again, going from left to right, off the screen that you don't see would be the centralized services, the hyperscalers, the big hosted versions of Kubernetes, large data centers, regional data centers. And as you move from those centralized set of services to the right, you run into these various segments of the edge, right? And the first segment that you run into is what we call the near edge, because it's nearest to the centralized services. And this is largely the realm of the telecommunications companies, right? The communication service providers. And there are very specific use cases that those companies need and we're trying to solve for. And just to look at this graphic, I want to call out some attributes of the slide here where the hard border is meant to represent locations, right? And so on the near edge, you'll see, deployment patterns where you have tens of locations to hundreds of locations to support, let's say, a 5G rollout or multi-access edge computing, we call it MEC. So lots of cool things happening there. The boxes within that hard perimeter are meant to represent the size of the hardware, right? So the big boxes there are kind of meant to represent big data center grade machines, classic TPU, rack and stack, things that we know very well from data center deployment days, right? And so this is the near edge. There's also a lot of demarcation there. And this matters to some telecommunications providers or communications providers because they are in the business of offering appliances or devices that sit on that line of demarcation. And the two that come to mind would be SD-WAN services, where it's a box, it sits on that line of demarc, it has connectivity into the customer premises and network management and connectivity back into the communication service provider network. And within that appliance, you'll have something like a lightweight version of Linux, K3s, for example, and then whatever the SD-WAN services or applications or containers that need to be run on that appliance. So you've got SD-WAN, you've got also SASE, S-A-S-E, for secure access services as appliances. But again, those we would classify as a near edge use case and application because they are owned and operated by the telecommunications company, and there's services that are managed by the telecom company. So we would put that in the near edge category. So moving again further away from the centralized services, when you get on the other side of that line of demarc, you run into what we call the far edge. And this is where the most exciting things are happening, the most diversity. And that hard border there is a slightly different color of green. That is meant to represent a few things. One, it's the physical boundary of that location, right? And inside that location, it also represents the layer 2 network that you have at that facility. And if you notice, the boxes there are very diverse. So you have large boxes, small boxes, mini boxes. These boxes are logically meant to represent the diversity of the cluster sizes that we have at the far edge. And in parentheses at the bottom there, you've got hundreds to tens of thousands of locations that would need to be managed, right? And so think of these boxes as Kubernetes cluster nodes, right? And you'll start to get the idea of understanding. What's interesting there is that the diversity is really extreme. So on one hand, you would have, let's say, a manufacturing company with a factory, and they've carved out a corner of that factory to act as a small data center. And there you would have fairly beefy machines, racked up almost like a small data center, right? So that's one side of the spectrum. And then on the other side of the spectrum, it goes all the way down to, let's say, a single Raspberry Pi running K3s and maybe one or two containers to do a very fixed function, right? And so that's why you have that diversity of squares there. And then lastly, just to finish out the definition, we have what we call the tiny edge. And if you notice, those tiny devices are within that physical location, right? Typically still within or on the same layer 2 network as the Kubernetes cluster on the left-hand side of the far edge, right? And so they're very linked, very closely linked together. And so we could talk about, once we get to kind of a more technical conversation, we could talk about things like AKRI, A-K-R-I, which is a brilliant framework that allows you to reach out, discover, and manage the industrial IoT space. So when you think of tiny edge, if you just think of industrial IoT, you'll totally get the picture. These devices are too small to run a full-blown stack, a full-blown Linux, a full-blown K3s, and then containers is pretty much too much of it's a heavy stack to run on these devices. But they do have software, they do enable protocols, and we need to reach out and speak that protocol to talk to and manage the tiny edge devices. So those are the three segments that we see in most of the opportunities presented within edge. So you've got near, far, and tiny, just to wrap that up. So, okay, now that we have a baseline definition, what are some of the challenges that we see for the edge, right? And so the main challenge is one of proliferation, right? So again, looking at the far edge use cases, we could be talking about 100 locations to tens of thousands of locations, right? And so it's a scale challenge. But not only is it a scale challenge, we all know that Kubernetes can be very complex, right? And so when you take on one hand the complexity of Kubernetes times, let's say, 6,000 remote locations, that is something we have to solve for. And so this is really the mission that's driving us at SUSE on the edge side. And so customers are looking for guidance, our partners are looking for guidance on how to support that, how to build that, things around reference architectures, best practices, where things break is important to understand, right? So, and we could talk about that technically when we get to more of the K3s piece. But lastly here, security is absolutely critical because in the classic world, we have security supported by a very hard perimeter around the data center, firewalls, defense in depth, physical barriers, things like that to protect the compute and storage resources that are in the data center. But with the edge, what we're doing is we're moving compute and storage resources from that hardened, protected, enclave, if you will, and we're pushing those out into very hostile environments, right? And so the threat vectors and the security posture of your Kubernetes cluster at these remote locations has to adapt to the new threats that are presented in these very hostile environments. And so security is front and center for us and should be for everybody, quite frankly. And we need to understand how we can protect our cloud native resources at the edge, right? And so what we want to do, what I'm involved with what I'm a big champion of, is to create an open source solution that checks those boxes, right? And it's a great story. It's a great mission. It's a great challenge. And this is something that we're marching toward. And I'll end my presentation here before we go into like the conversational part with discussing the overall vision that we have to kind of check those boxes. So here's how we see, using that same defining framework for edge, we see near edge, classic enterprise grade Linux, enterprise grade Kubernetes, and then workloads that run as normal. Again, where things get more interesting is here on the far edge, lightweight Linux, and then K3s, as we mentioned, would be a beautiful solution to drop in for that piece of the stack. And then because RKE2 on the enterprise side and K3s are both CNCF certified distros, your containers and your workloads and applications will just run as normal, right? And something like Rancher can manage across the board, and something like Fleet within Rancher helps us manage things at scale. And so here's where we're going a little bit in the future, which is really cool. And this goes back to that quote about anything below Kubernetes' overhead. Well, when Kubernetes was released, it was all about application deployment, application management, basically managing the state and performance of the containerized app that we deployed. So that's phase number one here with application deployment. What we've done with Rancher is we've used the same Kubernetes constructs and approaches to actually manage the lifecycle of Kubernetes itself. So any upgrades, upgrading K3s, for example, can be done from Rancher. What we're doing now is taking that same Kubernetes model and construct and going further so that to help resolve that scale challenge, we can now manage the lifecycle of the operating system, right? So now from the Rancher control plane using Kubernetes constructs and GitOps and all the goodness, as I said, that we've learned and gleaned from managing things in the cloud or at the data center, we can now point Kubernetes, Rancher and Kubernetes as technology to upgrade, let's say, Linux out into the field across thousands of clusters. So it's a really powerful construct. And so let me just finish the vision here, because our thing that's driving us is basically threefold. One, the lifecycle management of that stack. So going back to this slide here, this entire stack is what we want to manage using native Kubernetes constructs, right? So that's the first part of this vision here. We want to make it easy to use. We want to use GitOps. We want to reuse all the things that we've learned. Security is a big deal. I talked about that, but we need to make sure that we can trust what we're managing in the field. Again, it's a new environment. It's a hostile environment, and our security posture has to change. And then you can't do anything manually at scale. Automation is the key to all of that, right? So operating system updates, hardware management, onboarding. We have to have options for all the different type of hardware options out there. We have to be more multi-architecture. And so we have the beginnings of this, right, in the form of K3s and some other technology. And so we're very much aligned toward meeting this vision, and we're marching down the path to be successful here.
Okay, I think we've run out of time. It's an amazing topic. We could be for 4 hours, I guess. Well, again, Keith, thank you very much for making the effort to join us from Virginia, and I'm sure the attendees in our event will be really happy to have your insights and your vision on what K3s is doing and what are the challenges, and how SUSE is actively supporting this technology at the edge, right? So it was great to have you here.
Yeah, Alberto, I very much appreciate the opportunity, and thank you for providing the opportunity. So and everybody at the conference, have a wonderful time.